Hello! Get to talk about arrays, lists, and dictionaries real quick. Here's from the course website, from the introduction module. This is the second module. And we'll open up a Colab sheet. And you can create arrays from lists. We talked about lists in the basic introduction briefly. And here's a list that you can type. I just typed this one in. And you can convert the list to an array from the NumPy package. So you first import the NumPy package, and then you use the NumPy package, simply typing np.array for that method to be applied on this object, the list, to make a new array. And then here's your array. You're wondering why would we want to do that? Well, NumPy has a lot of great methods that you can use to manipulate and operate on that array. Another way is to, you'll often do this for generating plots, is to use the NumPy linspace function or method. So here is, you start at 0, go to 10.3 in 5 steps, 5 equally spaced steps. And that output is here. So you can see there's 1, 2, 3, 4, 5. So it's actually 4 equally spaced steps, but there's 5 numbers. Another method to create an array is with the arrange function, where again you start at 0 and go to 10.3, for instance. And this is a dedicated step size. So instead of the number of numbers, the total number count, or the total count of the array components, this is the step size. So it goes from 0 to 4, 6, 8, 10. So obviously it doesn't get to 10.3, but there are many cases where you'd want to use one or the other of these. Some array properties. You can get the shape of the array, which is basically the number of elements in the array. And if you set up a two-dimensional array, so right here I just have, this is a list, and then it's basically 3 lists within a list. And then I can convert that to an array and make a multi-dimensional array. And then it has 3 rows and 3 columns. The size of the array is, again, there's 10 elements in that AA array. And this one, of course, there's 9 for the size. And you can resize arrays. So this AA array, the original one is this, and you can resize it so that there's 2 rows and 5 columns. So there's the first row and the second row. Array indexing, so how you can index or find a particular value within your array. So my array has 10 items. If I generate this linspace 0 to 10 with 10 total numbers, there's 9 spaces or 9 steps. The first item in the array, you can reference it with this array 0. So that's the first item. Python is indexed from 0. Or you could call it the 0th item. This is 0, of course, this first one. And the 4th item, or the 3rd index, is 0, 1, 2, 3. That's the 3 value that's been rounded, in this case right here by the NumPy round, because I didn't want to show all of these digits for each one of the elements in that array. And you can do slices of the array. So right here I've got, instead of indexing it just once at 0, but there's a colon there, so I get the first 4 elements in the array. And I can again round this to 2 decimal places, so it doesn't print out all of the decimal places. And there's another resize example. Concatenating arrays, like putting 2 arrays together. We saw how to do that with lists with just the plus key. Here you can use numpys and concatenate. And I shorthanded numpy as np. Up here when I import it, import numpy as np, so I can access all of the numpy functions with np dot whatever. Element-wise operations. So if I have an array and I add them 2 together, for this array I get 5, 7, 9 as expected. And it will not do that if I have, it'll give you an error if you try to add a 3-element array to a 6-element array. And it'll tell you why. You can divide arrays element-wise and multiply them, as demonstrated here. Aggregation functions, so summing them or getting a median or a max or min. And we love our linear algebra, the dot products, it'll do that for you, as well as matrix inverse operations. So np-linalg is a matrix inverse, so I can solve systems of equations. So here I have 3 equations with 3 unknowns. The unknowns here are y, x1, and x2. I can reorganize that into this, and then in matrix notation, it would be this, because I take my top row, multiply by this, and it's equal to this top element here. Just another way of writing these systems of equations. And you can inverse that A array, multiply it by, or do the dot product with B, which is this, the constants, and get your solution for y, x1, and x2. And that's, I've done that here with np-linalg. Invert the matrix, and then multiply it or dot product with the 4, 7, 1 matrix, or in this case, an array. There's also, you can calculate the determinant. Sorting, so this will sort it alphabetically, and there's other, you can also do it inversely with modifications to this np sort. And it'll also sort numbers, of course, into incrementing. And you can decrement it as well. Searching, anywhere where the array is less than 4, it'll print out that array. And what index has the max? So that's the 7th one in this n array here. So 0, 1, 2, 3, 4, 5, 6, 7, 9.2, that's the max in that array. It's at the 7th position. And NumPy has, you can generate random numbers and put them into an array. So here I've got a 3 by 3 matrix of random numbers. I can invert that, another random number, because when you execute this, it changes every time. So I've got to import I didn't run my import up here at the top. Apologize for scrolling. I scroll down here at the bottom, and every time I execute it, it generates a new new random number. So similarly, this inverse of this doesn't equal that. It's not the same. Not the same matrix is given right here. How would you do that? You'd have to set it equal to my matrix, for instance, and then you would invert that my matrix. You can also have it generate random integers between, here it's 1 to 10. It's actually 1 less than this value, so 1 to 9. And here a size of 1 row and 4 elements. Dictionaries. We talked a little bit about dictionaries earlier, but another way to think about dictionaries is like a spreadsheet. You have the column name, the key, and the values. Here I've used NP linspace to generate 100 numbers between 0 and 1, increment that's spaced 99 times equally spaced apart. So there's 100 numbers there. Same thing with I've done here with generating a random temperatures, where this random number is between 0 and 1. So I wanted between 0 and 20, and then increment that to 20. So this is my bias. I raised it. So when my random number is 0, I'm at 20 degrees. And when my random number is 1, I'm at 40 degrees. Similarly, I can do the same with a pressure, for instance. And then I print my spreadsheet out, just named this dictionary spreadsheet. You have a time key with time values, temperature key with temperature values, pressure key with pressure values. And dictionaries are nice to use in data science. And with data science, there's an incredibly useful package called pandas. And I've imported it here. This is a very common thing to do in Python. Import pandas as PD. And then I can convert my spreadsheet dictionary into a data frame. And then this df.head, df short for data frame, and dataframe.head gives me the first 5 rows of my data frame, or in other words, my spreadsheet. It lists the columns given those keys. And I can make a new column called density based on my pressure and temperature, perhaps using, not specified here, but it is. I've added, converted this to Kelvin, and maybe converted this to Pascal, not specifying units here, but just as an example. And you can get a density and then reprint out the first 5 rows, and you get density. And it's pretty easy to plot with your data frame. Just df.plot and give it your x value, column or key, and your y values, and it will plot those for you. Hope that was helpful.